Hello, let's continue our Sudoku adventure with Parity Pairs by Matt Tressel. So we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this red line go diagonally. This is a parity mirror. So parity is the even or oddness of a number. So let's give the example here. Basically, it reflects the same parity. So it doesn't have to be the same number, but it has to be the same parity reflected across this diagonal. So the example is if row 4, column 2 is odd, say it's a 3, then we reflect across the diagonal to here. This is row 2, column 4. That also has to be odd. So it would have to be a 1, 3, or 5. If I made this a 4, that would break our parity mirror because that's even and that's odd. And so it wouldn't see another odd in the mirror or another even in the mirror. So if you think about it, you just flip the two coordinates. So, row 1, column 5 would flip to row 5, column 1, right? Or you can just look at the diagonal here, just trace along the diagonal and reflect. All right. We also have XV sums. So V, the digits separated by a V sum to 5. So if this was 2, this would be 3. 2 plus 3 is 5. Separated by an X, they sum to 10. So for example, 4 and 6, that sums to 10. All right. And then we have crop key. So digits separated by a white dot are consecutive. So if this was 2, this could be a 1 or a 3, so that they're consecutive. And black dots separate digits with a 1 to 2 ratio. So if this was 2, this could be 1 because 2 is double 1, or 4 because 4 is double 2. There's no negative constraints in this puzzle. So not all the XVs are given, not all the dots are given. If I have 2, 3 here, there could have been a V. There's not. It's fine. That can still be the solution. If I have 2, 4 here, there could have been a black dot. If I have 2, 3 here, there could have been a white dot. That's all fine. The only thing the dots and Vs and Xs tell you about are the specific cells they touch, not the cells they don't touch. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, so I know that X, the only way in a 6x6 to sum to 10 in 2 digits is 4, 6. Unless you can repeat, then it could be 5, 5, but it's in the same row, so we can't repeat. So we can just fill a 4, 6 pair there. V's are either going to be 1, 4 or 2, 3. So we can just fill 1, 2, 3, 4 into them. Let's see. 4 and 6 are, I'm going to use blue for even. 4 and 6 are even. And so those reflect over to here. Sorry, they reflect here. So these are even. What am I doing? This reflects to here, and this reflects to here. And so we have 2 even digits on a black dot. Now, I happen to know that's 2, 4, but if you wanted a way to think about this, a really nice way to think about black dots is one of the digits will be twice as much as the other. So if we think about what the smallest digit is, the only possibilities are so if 1 is the smallest digit, the other digit is a 2 because we have to double it. If 2 is the smallest digit, it gets doubled to 4. And if 3 is the smallest digit, it gets doubled to 6. 4 can't be the smallest digit because it would get doubled to 8, and there is no 8 in the puzzle. So our small digit is either 1, 2, or 3. But we know that both digits are even, meaning the small digit is even. So our small digit has to be the 2, and it has to be the smallest digit. We can't have it to 1. We have to double it to 4. And so there's a lot of ways you can think about that, but I think that's a nice clean way to consider that. So if we know that both digits on a black dot are even, then we know that it's a 2, 4 pair. Okay, what else can we do here? White dots are interesting because we know 1 is even and 1 is odd. Why do we know that? Well, 2 consecutive digits, one of them will be divisible by 2 and the other won't. Right? It's just one's even, one's odd when they're consecutive. Lots of ways to prove that. But as a result, that means that there is an even on this white dot. And if you look at this box, that means that we have accounted for 3 of our evens. 2 of them are here, and 1 of them is somewhere on this white dot. And there are only 3 even digits, 2, 4, and 6, which means these 2 have to be odd. I'll use orange for odd. And those reflect to here. And so we can put 1, 3, 5 here. Now, black dots, we can never put a 5 because you can't have it to 2.5 and you can't double it to 10. So the 1 would get doubled to 2 every time. And by the way, another thing that's nice about black dots that we can talk about is there's always at least one even on a black dot because you're doubling one of the numbers. And as soon as you double a number, you multiply it by 2, that by definition makes it even. And so this will be the even digit, which is going to go there as well, which actually the white dot would have told us that too. would get doubled to 2, 3 gets doubled to 6. An odd digit, obviously, you can't have, so you're always doubling the odd digit. So another way to think about not being 5 is 1, 2, 3. The odd digit will always be the smaller digit. And it's going to be a 1 or a 3. All right. Lots of ways to think about this, but the more ways you have to think about it, the more likely you are to discover something interesting. Now, of course, adding to 5, we're going to have one even and one odd, because in order to add to an odd number, the only option is one of the digits is even, one is odd. 2 evens add to an even, 2 odds add to an even. So one of each here, one of each here. We know there's one of each here. So, I mean, I could start like subcoloring, but I wonder if we can avoid that, if we're going to have to do that. So we know there's at least one even here. Okay, so we know a white dot has one even, exactly one even. We know the black dot has at least one even, and we know this is even. So that means the black dot does have only one even, so it's either going to be 1, 2, or 3, 6. 2, 4 is out, because if this was 2, 4, they'd both be even. This would also be even, and one thing on this white dot would be even. That would be 4 evens in the column. And so there's an even here, there's an even here, and there's an even here, and that makes this odd, which reflects to here. Okay. I think there were other ways we could have found that odd, but like the roping here, we know there's 2 odds and an even up here, and we know that one of the odds has to be on the V, and actually we know the even is on the V, and so that means the odd is here. One of each, one of each. One of each here. Okay, so we have 2 evens down here. So that means that we know that there's 2 evens here. Because whatever these 3 digits are, they go here. This is how, we call that roping. It's in 6x6 always ropes horizontally if you have normal boxes. So anyway, these 2 digits have to go in this box somewhere. They're going to end up here somewhere. Now we know we can't put the 4, 6 across the white dot, meaning one of the 4, 6s ends up exactly here, which does reflect across the diagonal there. And this is a 4 or a 6, but if you look, we have a 2, 4 pair up here, meaning this can't be 4. So this is the 6. This is not a 4 either, so this is a 2. And so now we actually know that there's an even on the white dot, and these 2 are even, so these 2 have to be odd. And this reflects up to here. We also know there's no 2 on this V, so it has to be a 1, 4 pair. 1 would have to go with 2 on a white dot, but 2 is used. So this has to be 4. So this is our even. This is our odd. We know that's odd. That reflects. Good. This is 3, 6 now. That's not a 3. Here, this has to be 2. So it's going to go to 1 because we can't do 2, 4, if you remember. So that's blue. That's orange. This reflects to here. And this reflects to here. All right. This has to be blue for the column. That reflects here. This is a 2. And this is odd, which reflects up to here. This is even. All right. Yeah, there was a lot of reflections we could have done, but I did them in that order. All right. This is 2, 6. That's a 6. That's a 2. 2 can't go with 5. That's a 5. That's a 3. So that's a 3. We get the 1 here. This is a 1, 5 pair. So we get the 5 and the 1. Here's our 6. 6 goes with 5. That's 3. This is 3, 5. 5 and 3. So 3 there. So this is not a 1, so this has to be 5. Okay, let's clean all this up. Not 1, 2. So this is 1, 2. So we add to 5. Can't put a 6 next to a 3, 4. So the 6 in the column goes here. That's 4. So this is the other 3, 4. And it can't be 3. So that's 4 and 3. 3 goes with 2 to add to 5. So this is odd, and these are both even. All right, we get the 2, 4 up here. This has to be 1. I think, let's see if I can finish the coloring before I finish the digits. What do we have left here? 1 of each. Okay, but we know the 1 ends up here. So the 1 is odd, and that's even. So that's odd, and that's even. Okay, perfect. So we get the 5 and the 1 here. We get the 4 and the 6 here, and we're done. All right, cool puzzle, Matt. I enjoyed that. I think the key deduction was this 2, 4 pair, and then the fact that this had to be even because yeah, so you can see that right at the start, and it took me a little bit to get back around there. But the fact that this had to be even because of the 2 evens down here in the white dot, and then this had to be 2, 4, made this a 6. And then from there, it did feel like it flowed really well. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.